Let's start with one more question. We have this complicated figure over here. We need to identify the triangle. We want to prove congruent. So we need to identify that what conditions do we have, what we need to prove. So let's start. In the given figure, OA perpendicular OD, then OC perpendicular OB, OA is equal to OD, then OC is equal to OB. Prove that AB is equal to CD. That's what we need to prove. So let's mention we need to prove AB is equal to CD. This is what we need to prove it, right? So first of all, we need to identify that which triangle this AB and CD belongs to. Most important part, right? We know this is about proving something, so we are obviously going to use CPCD, right? Whenever something like this is given, before that there is a one step, that is proving triangles congruent. Afterwards we can use this CPCD to prove these sides equal. So for that we need to have two triangles. So what are those two triangles that we need to identify that? So AB belongs to which triangle? AB belongs to triangle OAB, I hope, right? And CD belongs to triangle ODC. Clear? First of all, identify this one, that which two triangles are we supposed to prove congruent. So we can see very clearly AB, right? It belongs to this triangle, and here it belongs to ODC. So let's mention what we need to prove congruent for AB. Let's take OAB, and for CD we need to have ODC. These two triangles we are supposed to prove congruent. Let's write here. This is what we want to start. So the first step is to prove these two triangles congruent. So let's start. We have 90 degree over here. Can we start with the RHS? Let's think first of all, right? For RHS we need right angle. Not only right angle, we need hypotenuse and the side as well. Now opposite to 90 degree is what? AB. That's we need to prove equal. Now it's not possible. Whatever we want to prove, we cannot assume that it is equal, right? Always avoid the assumptions. So RHS cannot be used. Now here two sides are there. So for two sides you have two criteria, that is SSS and SAS, right? So you need one more side or you need one more angle, right? But observe, we have 90 degree over here. Let's use that only first of all. How can we use it? So let me redraw this figure so you'll come to know. Okay, let me just name this angle as angle 1. We are going to use the same strategy that we used previously, right? So first of all, let me draw here O, D and C, and A is somewhere over here, right? This angle is 90 degree. Let's say A is over here. Then let's draw OAB. So it is something like this, OAB, and somewhere here is C. Now observe this angle AOC, angle AOC. So this is what angle is here as well, and it is here as well, angle 1, right? So we are going to do what? 90 degree plus angle 1 and 90 degree plus angle 1. So what we will get? We'll get these two angles equal, DOC and AOB. This is what we are planning to do. Same as the previously what we did. 2 is equal to 2 we already have. Then if you add 3 on both of the sides, you are going to get 5 on the both of the sides. Same as Euclid's postulate. If equals are added to equals, answer will be equal. Same we are going to do. So first of all, let's start with the 90 degree. So 90 degree, we have DOA. Let's write angle DOA is equal to what we can write? DOA is equal to COB. Let's write angle COB. Now to both of these sides we are going to add what? Angle 1. So let's do it. Angle DOA plus angle 1 and angle COB plus angle 1. That being done, now value of that angle will be increased. In the first case, that will be DOC. So let's write DOC, and in this second case, that is AOB, that is AOB, right? So our angle is ready. We have the common angle now, I mean equal angle, right? So that being done, now about the sides, two sides are already equal if you observe properly. OD here and here it goes with OA. So then one side is equal. Now let's talk about OC. OC here and here OB. So if you observe, if we write in the way SAS, this is what side angle side criterion, right? I told you we are not going to talk about SSS. We need one more side, and there are no any common sides visible over here. We had angles, so first of all think in the direction of the angle only. So SAS criterion, if we use it, we can prove these two triangles are congruent. So we have the side. Let's start with this side first of all, and we'll conclude the sum. First of all, let's copy from the question itself. So OD is equal to OA. Side it is. Another angle DOC is equal to angle AOB, that is angle. And the one more side we need, that is OC is equal to OB. OC is equal to OB, that is side. So SAS. So let's mention by SAS criterion, we can write triangle OAB congruent triangle ODC, right? Very simple. Now what we need to mention by CPCT, simple, by CPCT we can write AB is equal to CD. See, AB belongs to this triangle and CD belongs to that triangle. Very easy to do, but it's all about how you see this question, right? First of all, AB and CD belongs to which triangle? Identify the triangle. So we identified the two triangles. We are going to prove those two triangles congruent, right? For that we have two sides, so either SSS or SAS. But why SAS we focused on? Because angle was given 90 degree. Now let's try to draw two triangles separately, and we come to know that we have one common angle, which is angle 1. If we add into it, we get the angle equal. So we did that calculation, then SAS, and by CPCT we proved that AB is equal to CD. So this is how we solve the sum. Let's do one more question. So we have the figure. It looks like parallelogram, but don't consider as a parallelogram if it is not mentioned, right? Many students are having this conception ki if it looks like that, then take it. Okay, ignore about that, how it looks like. Focus on what conditions are given. Mathematics is all about you have the condition, you have proof, then only you can apply it. We don't have proof that it is parallelogram, right? So this is the figure. Let's start with the question. In the given figure, AC is equal to AE, then AB is equal to AD, done, and angle EAC and BAD. Now what we need to prove, that BC is equal to DE. Okay, so BC is equal to DE. This is what we are interested in. Now observe over here, BC is with us, but AD is not in the figure. So connect it. We can connect here DE, right? Done. D is being connected. Done. Now let's start. So first of all, most important thing I told you was about identifying the triangles. Which two triangles are we supposed to prove congruent? Then by CPCT we can prove BC by DE. So let's start with the BC only. BC belongs to which triangle? BC belongs to which triangle? See, this is BC, and if we join these two sides, we'll get A. So for this, we need triangle ABC. And for DE, what do we need? DE, again, AE. This is what we need. So we can write, here we have written ABC. So here we can write ADE. For this, we need triangle ADE. And we need to prove what? Congruent, right? So we come to know that these are the two triangles that we want to prove congruent. Then it will be easily we can prove BC by BC is equal to DE. So let's start with the conditions. What's with us? I hope you must have got the idea for this sum if you've seen the previous one and try to solve one on your own, that this is very easy to do now, right? Okay, let's check for the condition. We have two sides and one angle. Two sides and one angle SAS condition. But let's draw this triangle ABC separately. So this is how it looks like, A, B, C, and somewhere this is D here, and this angle is equal. We have this and this AC, and let's draw it for ADE. So it is something like this, right? We have A, we have here somewhere C, right, and D and E. So this angle, right, and here double dash and here single dash. So you can see properly we already have two sides equal. This included angle is not equal, so let's make it equal. You know very well what we are going to do. Let's give name to this angle as angle 1, right? So let's start with angle only. First of all, let's write for this side, one side. It's good, it will be in order. AB is equal to, let's write AD. That being done, let's come to the angle. Two angles are equal. Let's write angle EAC is equal to angle BAD, right? These two angles are equal. That's what we have written. Now add angle 1 to both of them. EAC plus angle 1, and here BAD plus angle 1. Done. Now this has become, this is angle 1 and this is angle 1. Now this complete angle has become equal, right? So this is about this side. Now this is about the angle. Now what's the name of that angle? BAC, and here focus EAC is there. So here it will be DAE, angle DAE, and here BAC, angle BAC. So we have angle, side is done, angle is done. Now one more side we need, then our triangles are congruent. One more side is what? We have AC is equal to AE, that is side. So by side angle side criterion, we can write which two triangles? Triangle ABC congruent triangle ADE. Done. Now by CPCT, we can write BC is equal to DE, right? So this was the same concept as the previous one, right, about the angles only. But again, identifying these two triangles is the key step of the sum. If you identify which triangle to prove congruently, then only you can think in the proper way. Here we use the SAS condition. Two sides were given, one angle was also there. So we try to get the equal angle from the given angle, and this is how we prove two triangles congruent and the side equal with the help of SAS criterion. So let's discuss one more question related to this given figure. We need to prove some result or need to prove the triangles congruent. Let's start. In the given figure, if AC is equal to BC and DCA and ECB, two angles are equal, and another one DBC and the EAC, these two angles are equal, then prove that BD is equal to AE. So we need to prove this BD and AE as the equal. So how shall we start? First of all, let's mention what we need to prove equal. We need to prove BD is equal to AE. This is what we need to prove equal. And I told you, first of all, what is the most important step in this kind of questions? To identify which triangles we need to prove congruent. So BD belongs to which triangle? BD, this side is there and these are okay. So it will be BDC. So let's write triangle BDC, and AE belongs to here AEC. So let's write AEC, and it is triangle. And what we want to prove? We want to prove congruent. So basic idea, if we can prove these two triangles congruent by CPCT, we can prove BD is equal to AE. So our strategy should be on proving these two triangles congruent. Let's start. We have two angles and one side. Interesting. So two angles and one side. So either you have ASA or AAS, right? This is what we have it. First of all, let's draw these two triangles separately. First of all, let's draw AEC. So this is AC. Here E will be there. So A, E and C, right? This angle is there and this side, and here somewhere D is there, right? And this angle is also equal. So for the case of CB, let's CB over here, and this is how we draw it. So here B, C and finally D over here, and this is the angle, this is the side, and here somewhere E is there, and this angle is equal as well. So right now it looks like side angle, right? ASA, we have two angles and one side. So what we want to do over here, that again like we did previously, this angle is very interesting. This is the name DCE, and here DCE, right? That part is common in the triangle. So what are we going to do? We'll name, let's say, angle 1, and we will add in both of them, right? This angle is already equal, right? This two part is already equal, and if we add this same angle into it, so we'll get the same. So first of all, let's start with the angle. So we have what angle? Here we have DCA. Angle DCA is equal to angle ECB. Angle ECB. Let's add angle 1 here and here as well, plus angle 1, right? Now let's write DCA plus angle 1. So DCA plus angle 1, you will be getting ACE. So let's write angle ACE is equal to, now ECB, this is what till it is. Now we are adding angle 1. So it will be BCD, angle BCD, right? So we have one angle equal now. So if you observe, this complete angle is there, right? This complete angle is there, right? So this is angle, then side and angle. Here also angle, side and angle, right? So we are going to use A as a criterion. So let's start. First of all, just mention that which are the angles and which are the side, and that's it then. So we have the first angle that's being done, very good. Now we have this side, which is AC is equal to BC. So side is also done, and we have already one angle equal. So let's write over here angle DBC is equal to angle EAC, right? So we are done. This is angle. So let's write by A as a criterion, we can write triangle which we want to prove congruent, BDC congruent triangle AEC, right? This is not our final answer. Remember one thing, right? We need to prove BD and AE equal. So that's very simple. By CPCT, we can write BD is equal to AE, right? Corresponding part of the congruent triangles are equal. So this is also same question as we did previously, but here we have kind of triangle that is, like mixed with each other. and we need to identify the triangle BD and A. So BD belongs to triangle BDC, A belongs to triangle AEC. So try to get the angle equal here, because we already have two angles. One angle is out of that equal, but second indirectly given. So add common angle, so we get the two angles, and we have the included side as well. So here angle side angle. So this is the criterion that we use, and we prove two triangles congruent, and as a result by CPCT we prove BD is equal to AE.